Okay, hi everyone. This is Dr. Beebe, and I want to go through the highlights with you of chapter 5. Okay, all right, and these are the objectives for the chapter that you can look through. They're also posted with the presentation in our shell. So, what this chapter is talking about our study plans. Like if we're doing an epidemiological study, we the steps that we go through or in planning and designing it is what we're going to be talking about. So this plan consists of a research question. It consists of deciding what type of study design we have, whether it's exploratory, descriptive, or analytic. It talks about who makes up the study participants, what makes a person eligible or not eligible for our study, and how are we going to get these participants? What type of sampling design are we going to use? And then, of course, how are we going to measure it? How are we going to measure the variables? What type of data are we looking at? Are we looking at nominal data? Are we looking at ordinal data? And then, of course, we always have to think ahead to any statistical issues that might present themselves. So once again, when we talk about epidemiological studies, we're looking at research questions. And these research questions frequently answer who, what, when, where, why, and how. And basically, these research questions reflect the purpose of the inquiry. So it provides the plan that's going to help us answer this research question. So there's 3 broad types of study designs. There's exploratory, descriptive, and analytic. So an exploratory study is usually the first step in the research process. It's exploratory, so the problem is not clearly defined. And basically, it's used to help us understand the nature of a problem. So it helps us define that problem. And we use it to generate hypotheses. So we use it to generate hypotheses that we might use then in future studies that are more descriptive or analytical. It may involve reviewing current literature, literature and studies that have already taken place. It could be kind of an informal qualitative approach. And qualitative, frequently we use focus groups, we use interviews, or it could be something that's more formal, such as case studies or pilot studies. Descriptive studies, however, involve numerical data and statistical summaries to help us facilitate an understanding, a better understanding. These can also be useful for generating hypotheses. It allows us to understand the population or the issue that we're talking about. Analytic is what we use to test the hypotheses. So for this, we're actually going to look at what type of association does or does not exist, possibly between exposure or risk and the health outcome that we're looking at. So the first thing we have to decide is who is best to answer our research question. So who are our study participants going to be? The sample is a subset of the accessible population. So this may be required in the population affected by the health problem at large. So we're going to come up with certain eligibility criteria. So criteria that's going to tell us who can be included and who would be excluded. So inclusion properties might be older than 18 years of age. Inclusion might be no chronic health issues. Exclusion might be less than 18 years of age, chronic health issues, so those are the types of things that we'd be listing in our inclusion versus exclusion. And then we have different ways of sampling. Okay, so we have simple random sampling, and simple random sampling is literally when we are, like, if we have a large population and we use a number generator that just picks so many random numbers that are assigned to individuals. Okay. And then we also have systematic sampling, in which we are looking for more specific inclusion. And then we have stratified sampling, in which we will look for a subset within a set. So maybe that stratified sampling might be that we're looking for university students, but we're looking for female university students. So we're looking at a stratified uh, and versus cluster sampling, in which we are kind of grouping the subjects together and pulling from that sample. Some non-probability sampling, okay? So what we just went through was probability sampling. So this is looking at the fact that everyone would have an equal opportunity for being selected, okay? So that's a more preferred method. However, it's not always something that we can use, or it might not be the best for a certain research study or research question. So we have other things or other methods of sampling that are non-probability. So convenience sampling, an example of convenience sampling might be that I am looking at different ways to teach a class. So I'm going to use my students who are conveniently in my class as my sample group. Okay, so that means then I have this convenient sampling that I can use for my study. Now, the problem with that is that it's non-probability sampling. So it's a very select group. So it's not random. So it does have might have some confounding variables in it. And then snowball sampling is when we have something where I might pull someone from a classroom and then I give them a QR code or something like that, that they can then give to their friends. And then those people can give that same QR code to their friends. So it's almost like a snowball. So by the more people that I give it to, the greater likelihood that I'm going to get more people. Okay, so that's an example of kind of a snowball sampling. Consecutive describes things that are one after another without interruption. Okay, so they can refer to consecutive sampling refers to gathering data from available subjects over a period of time. As However, judgment sampling selects excuse me, selects subjects based on a researcher's expertise, and quota sampling basically aims for a representative sample by filling predetermined quotas for different population subgroups. So perhaps we might want to have so many females and so many males in our studies. So we'll keep taking male subjects until we get to that number, and we'll keep taking female subjects until we get to that number. Okay. And then recruitment is the process of then bringing in these subjects. And of course, the goal for this is to get a representative group from the target population. We need enough participants. We want to make certain that we have numbers that are large enough so that our results can be statistically significant. And it also allows us to avoid non-response bias. So if we have a small group, if we only have 25 participants and 5 of those individuals do not respond, that creates a bias within our data because that's 20% of our target population. And then we have to look at the variables, okay? So this is when we are kind of moving from that conceptual framework and we need to build the constructs of our study into variables. Okay, so these are the properties that are going to be observed or measured, and these are going to be attributes that describe a thing, an idea, a person, place, or time, and whose values can vary from one participant to the next. So now we're going to talk about different types of variables. We have categorical, which would be numerical or ordinal. I'm sorry, nominal or ordinal. And then we have numerical, which can be either discrete or continuous. All right. So data. Data is that information that describes our observations. It's also, or it might be measurements of something of interest for us. We get data. Data can be quantitative, it could be qualitative. We get it from observations, questionnaires, interviews, experiments. And once again, we're not just talking about numbers, we're also talking about words or observations, or descriptions that are more qualitative in nature. So descriptive epidemiology studies measure the number of cases. We also will pull data on the demographic information, so male and female, those types of things. If there's a case status that's involved, so whether it's hospitalizations, deaths, or case status might be university students. The timing and distribution of the cases, so if we are looking at epidemic curves, and of course, exposure information to whatever risk factor we may be looking at. Analytic epidemiological studies measure how the change in one outcome variable relates to the change in the exposure variable. So we might be looking at a risk factor such as not using sunscreen and the outcome being that of skin cancer. So once again, we have different types of variables. We have the exposure and the outcome. And once again, the exposure we've talked about before, that's the exposure or the risk factor. The outcome is whatever health issue or outcome we are looking at. And the effect modifier is one of the variables that we're looking at as far as how it affects the subject. And then a confounding variable is one that will impact what we measure outside of our design. So how do we collect this data? One of the most common ways is through a survey. And this is when we have a questionnaire and the process of collecting and analyzing responses to the questionnaire. A questionnaire is basically a set of questions that we design to obtain information from a particular, and these will be designed for that group of individuals that we are targeting, and it will be designed for whatever exposure or outcome that we're looking at. Now, this goes into a lot of detail as far as creating a new instrument. When we say new instrument, we're talking about a questionnaire, okay? So we're going to go through this rather quickly because this is a little bit beyond kind of an intro class because you won't be designing your own surveys or questionnaires. But anyway, so when you're building a new survey, you ultimately will design a tool or an instrument that is broader than the topic that you're looking for. Okay, so we're actually building it with more questions than will probably be in the end. Okay, and we run a lot of pilots with new surveys because when you write something, you know what you mean. So when I write a sentence, I know exactly what I mean. But when someone else reads it, they might interpret it differently. Whether I used a word maybe that isn't as common, or if I used a word that might have multiple meanings, I might be designing something that's not completely clear or might be misinterpreted. So frequently, when you design a survey, you want to pilot test it and have people read it and ask them if they understand what the question is, okay? Because clarity is incredibly important in these questions. Otherwise, we're asking questions that don't get us to the points that we need to get to, okay? Frequently, in addition to pilot testing it within members of the target group, call on colleagues, okay? Run it by colleagues, see what they think, okay? So these are all ways that that we can design a new instrument to make certain that what we're asking is getting to the questions that we need to answer our research question. So we can also look at existing data. Okay, so we can look at secondary data, which would be data from someone else's study. We can look at ancillary data and systematic reviews. Okay, so secondary data is existing data that we can use to investigate our research questions. So frequently, there are large data sets that you can use, large hospital data sets um, that you can use to comb through for your particular research study. Ancillary data comes from adding one or more measures to a study, often in a subset of the participants, to answer a separate research question. So if I'm running a research study, I can actually collect ancillary data by pulling a subset of our participants and asking them kind of a separate research question. Systematic reviews are a wonderful tool to where you're pulling all data that has been done prior to your research on the same topics. And what that allows you to do is that allows you to learn from people who have run similar or very similar studies. Okay, so it allows us to understand the target population better. It allows us to learn from their successes, learn from their mistakes, and I don't mean mistakes in a bad way, but at the end of every research study, there's always a section, the discussion where they discuss things they would do differently if they were to do this again. You can learn a lot from past studies that have been done. And then we can also have a meta-analysis, and this is a more statistical aspects. So the systematic review is more narrative, while the meta-analysis is going to be more statistical aspects of those types of reviews. So some statistical issues that you can run into, data analysis in the sense that, is this a triple blind study? Is the analyst blind to who is the experimental group, who is the control group? And the reason I say that is because we don't want people rounding up or rounding down. Okay, I'm not saying people purposely do this or try to purposely mislead, but the more effort we put into making certain that we're trying to control all these variables, the better. Okay, sample size might be a statistical issue that we come up against. Maybe our sample size isn't large enough to make our results statistically significant. Management, the management of the project or the management of the research study, and of course, when we're looking at designing methods. So as far as statistical methods, there's different types of data, okay? So there's categorical data, and there's numerical data, okay? So nominal data is when we have labels or names for categories with no inherent order. So an example of this would be types of fruits, colors, male versus female, exposed, yes or no, marital status. These are all categorical, okay? They're types, they're labels, they're names, but there's no inherent order. Okay, so divorced is not better or higher than marriage. Education level, one is not higher than the other or lower than the other. Colors, one is not higher than the other one. So this is nominal data. Ordinal data then is categorical data again, but there is an inherent ordering. So this is something like, if you get a Likert scale, so when you're filling out a customer service rating and it's poor, average, or excellent, okay? We know that there's an inherent order from poor to average to excellent. Okay, so those are examples. So there is this kind of ranking or preference rating in ordinal categorical data. And then we have numerical data. And numerical data is either discrete or continuous. Discrete or numerical data is quantitative data that can only take specific separate values. And these are going to be typically whole numbers. Okay, so questions like how many students are in the class? Okay, you can't have 12 and a half students. Okay, so we're looking at these whole numbers. Numbers of car in a parking lot, number of cigarettes that smoke, just discrete, finite numbers versus continuous data in which there's infinite values. So these are ones that can be fractional. These are ones like height, weight, temperature, all examples of continuous data. So if we're describing nominal and ordinal data, okay, we might look at something like the frequency of distribution. And this is going to tell us the number of observations for the possible values of a variable. So here we're looking at an example of COVID-19 on May 3rd, 2023. Okay, so here we're looking at this data and we're separating it into these categories of less than 40 years of age, 40 to 49, 50 to 64, 65 to 74, and so on. So we are looking at these observations and we're separating them into a distribution table and how those numbers were distributed based on age. And then relative frequency is another way that we can look at this data. And then we're looking at it within the total number. What is the relative frequency of individuals 40 to 49 years of age? Okay, so here we're looking at, out of all of those, what's the relative frequency of being 40 to 49? And then we can also look at proportions and rates. So a proportion is a number compared to the whole. Okay, so these are going to range from 0 to 1, and they're often going to be presented per 100. Okay, so basically in a percentage. Okay, and a rate is a proportion with an added dimension of time. So we might be looking at the number of cases compared with the population at risk during a specific time interval. And then rate is looking at the frequency distribution table that we looked at a couple slides ago. And we'll include those specific rates per 100,000 people, okay? And the reason that's important is because when we create a rate, okay? So if we know that in the US, 16.07 per 100,000 of individuals less than 40 years of age had COVID, okay? We can compare that then, because it's a rate per 100,000 people, we can compare that to other countries with different populations. Because otherwise what happens is when you try to compare, if we were to try to compare the numbers, the raw numbers, such as like 28,216 in the US to the raw numbers in a small country like the Bahamas, we can't compare those two numbers, but we can compare rates per 100,000, okay? Because the the denominator, or that per 100,000 people, will be the same for all data that we do in this method as a rate for all countries. So it allows us to compare between countries. A ratio is a relationship between two quantities, excuse me, and it's usually going to be expressed as one being divided by the other. Okay. These are examples. This table is in your book. I'm not going to have you actually calculate any of these numbers, so don't worry about that. But if you look at table 5.5, it gives you kind of the incidence and mortality rates and prevalence proportions that are used in epidemiology. And it tells you kind of what's in the numerator, what's in the denominator, how it's expressed, and what's it's measuring. Okay. And these are some basic notations and statistics. I'm never going to ask you these. I think this is, once again, kind of beyond our scope. Same with all of these formulas for descriptive measures. We will talk about the geometric versus arithmetic mean, but I'm not going to have you actually calculate that. So sometimes we like to look at central tendency. Okay, so many of you, I'm sure, have calculated the arithmetic mean. Okay, so the arithmetic mean is basically when we talk about finding the average. So basically, we sum up all the values and we divide it by how many there were. So if we have I'm just trying to think, the temperature in town for 5 days, and we're trying to figure out what was the average temperature over those 5 days. We can add up those temperatures and divide it by 5 to get the arithmetic mean. Okay, so that's what that is. The geometric mean is a little bit more complicated. Once again, I'm not going to have you do any of these, okay? But for the geometric mean, it's the nth root of the product of n values. Okay, so we use the geometric mean for when we look at growth rates. The median is the middle value in a sorted list. So if we were to line up all of the measurements, so if we were to line up all of the temperatures for a month, and we line them up in order from lower to higher and just count to the middle one, that's the median. The mode is the number that's going to be the most frequent value. So when we lined up all of those temperatures, okay, the median might be 71. However, the mode might be 73, okay, because it was 73 more days than any other day, or any other temperature, excuse me, okay? So in these studies, when we design these, we have to figure out, what is the best measure of central tendency for our purpose. And then also we can look at variation. How do we measure variation? This is also called dispersion. So how big of a range do we get from that median or from that mode or that arithmetic mean? Okay, so how far are we from? Common measurements of variation include variance, standard deviation, range, interquartile range. Those are all measurements of variation. Okay. Degrees of freedom, once again, we're not going to concentrate on that, so I'm going to go through that. Um, Then we can also look at confidence interval. Now, we are not going to calculate confidence interval. I want to mention it to you because it is a great measurement of reliability. Um, and reliability is important as far as evaluating it objectively. Okay. So basically, a confidence interval defines an upper and lower limit associated um, with the estimate of associated probability. And then we look at describing data. So we've run our study, we've collected our data, whether it was numerical, whether it was nominal, ordinal, whatever it was. So how are we going to describe that? How are we going to display that information? How are we going to communicate that information to others? Okay. So a table is one way of doing those. You've all looked at tables and made tables, I have no doubt, where we organize the data into rows and columns. We've also frequently used graphs. Graphs are very illustrative. We can show an association or a relationship very simply with a line graph. Okay. This table from your book, once again, we aren't making all of these. There's many that are listed here, many graphs for describing data. It's a nice table to have as a reference, but that's about that. All right, and then of course, here's the summary. So there is a lot of stuff in this chapter that's very important, but then as you notice, there's also a lot of stuff in here that I think is a little bit beyond the scope of this class, the scope of an intro class, any intro epi class. That's more on the level of like a 400 level epi class. So, concentrate on the things that I highlighted. Once again, I'm not going to have you calculate any of these data calculations that are presented in this chapter. Once again, if you have any questions, let me know, and I'll talk to you guys soon. Thank you. Bye-bye.